Welcome to Technically You, the show that makes networking, cybersecurity, and innovation simple enough to explain to a preschooler. Okay, maybe not.
Anyway, today we're exploring a topic that underpins nearly every home and business network worldwide, NAT and PAT. These technologies are like the multilingual translators of the internet, and they're quietly doing work every time you send a meme, video call, or stream AI-generated videos.
Hey, I caught that last part. So let's kick this off. What exactly is NAT, or Network Address Translation?
Great question. NAT is a method used in routers to translate private IP addresses used within a local network into a public IP address for communication across the internet. It's essentially a bridge between internal networks and the wider internet.
Right. Because inside your home or business, devices use private IP ranges, like 192.168XX or 10XXXX. That can't be routed on the public internet. NAT is what allows those devices to talk to the outside world using a single public IP.
Now, PAT, port address translation, is a specific type of NAT. You'll sometimes hear it called NAT overload or NAPT, which stands for Network Address and Port Translation. Instead of assigning a different public IP for each device, PAT uses a single public IP address, but differentiates each device in session by assigning unique port numbers.
So if NAT is a translator, PAT is the translator with a clipboard and a stopwatch, keeping track of every conversation by port number.
Exactly. If 10 devices in your house are browsing the web at the same time, PAT ensures that the responses all go back to the right device. It tracks each connection by mapping the internal IP and port to a unique external port.
So why do we use NAT and PAT? What problems are they solving?
Three big reasons IPv4 address conservation. There are only about 4.3 billion IPv4 addresses, and we have way more devices than that. And that lets us use one public IP for hundreds of internal devices. Security, internal IPs are hidden from the public internet. This adds a layer of protection. Routing simplicity. With NAT, internal networks don't need to be globally unique. That makes configuration easier and networks more flexible.
With PAT, we gain even more scalability, particularly for home routers and small businesses that typically have only a single public IP address from their ISP.
Let's take a real-world example. Say your laptop with IP 192.168.1.50 sends a request to YouTube. Your router uses PAT to rewrite that source IP to something like 72.1.4.94.30:57432, the public IP and a unique port.
When YouTube sends the video back, it replies to that IP and port, and your router translates it back to your laptop. Multiply that by every device in your house, each using a different port.
Okay, listeners, it's also helpful to know that NAT has variants. Static NAT, one-to-one mapping of private to public IPs. Rare in homes, dynamic NAT, maps private IPs to a pool of public IPs. PAT, overloaded NAT, many private IPs using one public IP with ports.
PAT is by far the most common, especially in home networks and most businesses that don't own huge blocks of public IP addresses.
Let's break down the benefits. Address conservation, crucial until IPv6 becomes widespread. Security, internal IPs aren't exposed. Flexibility, easier to set up private networks.
Also, PAT enables massive scalability. You could theoretically have thousands of internal devices sharing a single public IP.
Of course, there are challenges too. Complicates peer-to-peer connections, gaming and VoIP, because external devices can't easily initiate connections back. Breaks end-to-end visibility, which some security and troubleshooting tools rely on. Port exhaustion. In high-demand networks, the number of available ports, 65,536, can run out.
That's why in large enterprise or data center environments, NAT is often replaced by public IP assignments, VPNs, or IPv6 solutions.
So what happens as IPv6 adoption increases? Do NAT and PAT just go away?
Not quite. IPv6 eliminates the need for address translation by giving every device a unique IP. But many networks still use NAT 66 or similar mechanisms for policy enforcement and topology hiding. By the way, NAT 66 is a network address translation method used in IPv6 networks. It allows multiple devices on a local network to share a single public IPv6 address.
Also, transitioning fully to IPv6 will take time. NAT and PAT will still be around for years, especially in dual stack, IPv4 plus IPv6 environments.
So, NAT and PAT are like the unsung heroes of the internet. They're hiding in plain sight, keeping traffic flowing, devices reachable, and networks safe.
Absolutely. Whether you're managing a small home setup or a corporate infrastructure, understanding these technologies gives you better control, more security, and fewer networking headaches.
Well, techies, that's all we have for today. Please subscribe to Technically You for more tech made simple, one packet at a time.
Yes, see you next time. As always, stay connected and stay curious.